Hello, everyone. And thank you for those of you who stayed for the startup pitching session. I think it's very important to support the startups, especially in their early journey. So thank you for being here. Okay, and for those of you who are not familiar with Kai Ventures, we are the organizers of this competition, which is going to be more like a battle due to government issues and travel issues. So we have two startups pitching today, and this is why it's going to be quite fast. But a little bit about us as Sky Ventures, what we do and who we are. We are an ecosystem builder that uses a VC fund and a startup accelerator as instruments to grow the global quantum ecosystem. And I'll be very quick. We are based in Basel, and we were born out of a stronger and long-term vision of our main investor that wanted to build something for the future of his grandchildren. So we were born last year in 2023, and to grow the ecosystem, we are using these building blocks. So the investment, we have a VC fund, and also an accelerator program that we are running out of Basel, Switzerland. And also now we have an office in Calgary, in Canada, together with Quantum City and the University of Alberta, of Calgary. We invest in startups all over the world. We focus mainly on quantum technologies and advanced AI. And we invest in all the stages of a startup, and our goal really is to support the development of projects out of the laboratories and academia and all the way to IPOs. And here you see, the tools that we are building. We are very open to collaborations. We are very open to partnerships with everybody that wants to contribute to the growth of the quantum industry. And that includes academia and corporate investors, of course. Yeah, we're very friendly. And this is our ecosystem right now, based in Uptown Basel, as I mentioned before, which is becoming quite the quantum hub. We have IonQ present on site with the first commercially viable quantum computer that they are building there. D-Wave is also one of our colleagues on the site, on the campus, and we also work with QERA and a lot of other hardware providers. We really want to connect the startups that are part of our portfolio to the most impactful companies out there. And as I mentioned, we also opened an office in Canada. We are organizing a hackathon in October as part of the Q Connect event. And if anyone here wants to apply, if you're in academia or if you just want to contribute to developing a use case for the sustainability goals, please feel free to go to generationquantum.tech and you will get a lot more information there. And this is us. As I said, we started last year in March. Now we are a team of 8 in Switzerland and 2 in Canada. And we are growing very fast. And we also work with a very important network of mentors, because we don't know everything. We know we don't know everything, but it's important for us to have as many people that know as many things as part of our network. And we organize the sessions between the startups that join the accelerator program and our mentors. And as you can see, there are quite some knowledgeable people in our mentorship network, and we're very proud of keeping to grow this network. These are the startups in our portfolio. They are either coming via the accelerator program or directly as a fund investment. And it's growing and growing, and we're very proud of it. We also have AI startups in here, like Phoenix Technologies. They are building a sovereign cloud out of Switzerland. Moonlight AI, they build also a use case with one of our partners trying to integrate quantum into the development of AI, and we have a lot of certain projects like this. So our mission is really to empower the global transformation with investments and accelerator program, but focusing really on the ecosystem building. So if you would like to learn more about us, please come to me or James. He's my colleague that's also here today, and we can tell you a lot more about what we do. And we are very proud to partner with Q2B and organize this pitching competition. This was a very incredible learning experience for us. It's our first time in Tokyo, First time in Japan and actually first time in Asia, participating in a proactive or like active way in an event here. And I would also like to thank the tech team in the back. I don't know how much recognition they get throughout the day, but they did an amazing job of like fastly incorporating our slides so that we're ready right now. So thank you guys in the back. And yeah, you know, as I said, due to certain visa issues and traveling issues from Europe, we originally started with 6 startups that we're going to present today. Now we ended up with more of a battle than a competition, so we only have 2. And, you know, it has pros and cons. It means that we guys all get to go to lunch sooner. But unfortunately, we will not get to learn about more quantum projects. But also that gives me the opportunity to talk a bit longer, so I'm not in a rush. Okay, so we are joined by an amazing group of jury, and I'm very well aware that we have 3 times a larger jury than the competitors. But I'm also very grateful to you guys for being here. And I know that, you know, the capacity of the brains that are here in the first row is amazing. And I'm looking forward to hearing your questions to the projects and also your feedback. The winner of this competition is getting fast track in our accelerator program. So when we select the startups in our program, we really focus on quality rather than quantity. And we have a very detailed process, right, to select them. So the winner of today will skip a few of those stages and go straight to the, James, what do we call it? Speed dating. Thank you. To the speed dating, which is the last phase of the selection process, where we invite a large number of our mentors in Basel or in Calgary, and they get to meet the startups one-on-one throughout a whole day of questions and learning more about what they do and who they are. So thank you very much, Alexander Kiesling. He's from QEra, the CEO of QEra. Nardo, he's one of our very close investors from the US, and he's really specialized on quantum investments. Tommaso, you probably are more familiar with him. He's a regular in Tokyo. He's with Antropica Labs. Andre, he's with the Global Quantum Intelligence, collecting a lot of data and really promoting the quantum industry and what's happening all over the world. James, he's my colleague from Kai Ventures, and he's the director of the accelerator programs. And Takumi, I'm hoping I'm not messing up the name. He's with NTT Data, and he's a quantum expert. So we have quite a varied set of skills in the jury. And now so thank you all. And now we are going to start with the first speech. Who's ready? Thank you. Come on, guys. We're just a few. This is like a small family gathering, right? So let's have fun.
Good afternoon, everyone. My name is Teik Guan from Singapore, and thank you to Kai Ventures for allowing us to come and pitch. So I'm CEO and co-founder of pQCee. I'm going to be standing a bit here, so I apologize to the judges who might be angling your neck, but we're here to really try to make the world be quantum ready. So what is happening? Well, you've heard a lot in the morning about how we're going to get quantum, going to get all the advantages that is going to help. Quantum is going to help businesses make money or save money. And that's all right, that's all true. But that's going to happen only in a 5 or 10 year time frame. Before that, we actually have to fix the elephant in the room, which is the risk that quantum computers bring. There is a threat that quantum computers will bring, and that is in the cybersecurity space. Unfortunately, the speed-ups in quantum computing that does for the finance industry, for the automotive industry, for the chemical industry, it's going to do bad things for the cybersecurity industry because the cryptographic algorithms that we are very used to today are going to be broken. Broken how? It's going to be broken in the way that happened last week. You know, the blue screen of death? It's probably going to be the same thing. And that's something that we probably have to fix and address before we actually get to use the quantum computer for good. And this is really what we are actually seeing when we are speaking to a lot of the organizations within the banks, within the government, who says that, hey, before I start to save money or make money for my organization, I want to save my job. I don't want to be fired when quantum computers come. And that's really where we come in. And this is really about all kinds of projects that we're talking about, from Bitcoins to your digital certificates, to your identities, to your documents, even to your smart factories. All of them will be affected when a quantum computer comes, because the cryptographic algorithms that is being used and assumed to be safe is no longer safe. And this is a market that we realize can be addressed today. We are already getting a couple of customers, which I'll share with you a bit more. But let's go into the technology side of things first. So when I keep talking about cryptographic algorithms, what am I saying about? We're talking about Alice and Bob. Alice is sending a message to Bob, and Alice needs to make sure that that message gets to Bob unchanged. Bob needs to know that the message came from Alice. Bob needs to know that the message is not changed when it's being sent, and Bob needs to be able to prove that that message came from Alice. Wow, that's a lot of assumptions that we take for granted. That's because the cryptographic algorithms based on public-private keys actually do the trick. Unfortunately, that assumption is broken. Given the public key, which is public, a quantum-capable attacker can calculate the private key. And that's going to happen when logical qubits hit, 2,000, 3,000 logical qubits. Not very far off, if we believe what IBM says this morning. So when that happens, anyone can impersonate as Alice, and Bob cannot tell the difference. And this is something we have to fix. What is the world doing right now? The great guys at NIST, the National Institute of Standards and Technologies, are trying to come up with new algorithms to say, let's replace this algorithm, let's change it to something else. Let's move from RSA, let's move from ECC into lattice-based cryptography. It may work. Unfortunately, it's not trivial. It's really, really, really difficult to try to migrate algorithms at that level and expect Alice and Bob to upgrade at the same time. Again, the blue screen of death last week comes to mind. Trying to upgrade everything at one shot in one big bang is not for the faint-hearted. What we have come with, at least from my startup, is that we are able to make the existing algorithm quantum safe. We're going to make ECDSA, the signing algorithms, quantum safe by starting from a pre-image, which is, am I missing some? Oops. Okay. So, which is a secret that hashes to the private key, and this itself is a quantum-resistant process. And if we then layer it across with a zero-knowledge proof, we effectively make the existing digital signing system quantum safe without having to migrate to the new pQCee algorithms in one big bang. It allows for a gradual, backward compatible, seamless way to slowly get in, because Alice can start the upgrade process and Bob won't tell the difference. After Alice has upgraded, then Bob can start to upgrade. And this is something that we realize can already be done. So we have built a first product. It's called Inoculate. It's for PDF signing. So imagine if you are doing millions and millions of PDF documents. Every organization has it. And you want your PDF documents to be secure even when a quantum computer comes. This is the product for you. We have deployed it in one of our customers in Singapore. And the great thing is they didn't even need to upgrade their Adobe Reader. It already works as it is. And that's really what we're talking about. So we are really doing a lot more. We're exploring a lot more use cases. Beyond PDF documents, I'll give you an example. Blockchains, Bitcoin. Bitcoin is also vulnerable to quantum attacks. Right, the key in the wallet signs with ECDSA and it's put onto the chain. Anyone with access to the chain, which is anyone, can use a quantum computer and calculate the private key here. And Bitcoin, Ethereum cannot upgrade to the NIST algorithms because changing that would affect the public key and the wallet address, causing hundreds of millions of wallet addresses to change at the same time. We actually have the way to solve it. And that's, again, based on the seed phrase, and we provide a zero-knowledge proof, and this is all done. We have actually published an EIP on this and slowly trying to get this done into the real world itself. So lots of stuff we can do, and the team to do it is myself. I'm a repeat founder. I previously exited my previous startup in multi-factor authentication to Gemalto, retired for a while, midlife crisis, went back to do my PhD in quantum cryptography, and now I'm back doing my startup. My co-founder, seasoned finance professional, chartered accountant. She runs the ops, finance, basically all the non-fun stuff. I do the fun stuff, she do the non-fun stuff. Life is good. We've really raised a pre-seed round. Still okay, but more money is not that. And lots of work to do from now. Expanding our reach, getting more customers, growing our use cases, and essentially doing a lot of standardizations. So my time is up. I guess I have to open the floor for questions. Thank you very much.
Thank you, Teik. Now, questions from the jury.
Thanks for the presentation, Teik. Thanks. My question is, do you feel like your solution is a temporary one before, the NIST standards kind of come out, or is it something that stays and then you layer the NIST standards as part of like a, cryptographic layering of?
So, and you are very right. We believe that solution that we have is a temporary one. Temporary in terms of, say, a 15, 20-year time frame, right? Cryptographic migrations are counted in decades. How do we move from single DES to triple DES? How do we move from triple DES to AES? They are all counted in decades. And that is the time that's needed to do that migration. We believe that we have this, for lack of a better, we are Band-Aid. We're selling Band-Aid right now for the next 5 to 10 years to help organizations start to become quantum safe. And in that process, we provide this algorithm that can help them get towards a quantum safety, but with a longer term goal of moving to the NIST standards. So the NIST standards don't go away. It's just that it's so difficult to get there that we will help them go in a less painful and easier way. And from a pQCee standpoint, it's not so much that just because we don't have this just because it's a temporary solution doesn't mean that we cannot get there, because it's really about landing and expanding. Lots of organizations need a lot of helping hand in order to guide them into the quantum readiness world. And if we are that first stop for them, then getting from a temporary solution to a longer term solution, even partnering with all the people here to grow our market and provide even quantum computing capabilities, that's really a much longer term goal that we can do. But we become the first point of contact to that customer, and that's something that we want to do.
And will you be the second? Will you be, meaning if you put your solution in there,
Yep.
so you already have the vendor advantage,
Yes.
right? Is it a replace, when the NIST standard comes, or are you layering?
So I give you an example of what we have, right? So I introduced about the product, this Inoculate, which is a document signing product. This is already sold to a finance company in Singapore. We're starting another one pretty soon. And in fact, what we have worked with the Singapore government is that we've gotten a grant from the Singapore government to enhance this with the NIST pQCee algorithms, to enhance it into a much bigger blown implementation where it's not just about simple document signing, but a full-blown PKI that has hybrid both secure signing plus digital certificates with NIST certificates all inside the same product itself. So we will be constantly advancing and enhancing that product itself. But what we realize is that a lot of customers don't want the full-blown thing. They just want something simple to let them get the journey started. One more.
How do you stress test the security of your solution? Like, do you get any other third party, for example, to actually check that the security is valid and is resistant?
Fair. So two ways, right? We from a company standpoint, we do it from the design itself. We are using standard algorithms. I mean, we're using ECDSA, we're using SHA-256. The zero knowledge proof we're using is the PICNIC algorithm by Microsoft in the round 3 of the NIST competition itself. From a standards or a third-party certification itself, we're getting started on the EAL certification for this product. The great thing is because we are still using ECDSA, we're actually not moving away from any new standards. So we are working with a standards body in order to get this product EAL level 2 certified based on existing standards. Thank you.